Section 5.6 combines the last two sections together. In Section 5.4, we solved compound inequalities. In Section 5.5, we solved absolute value equations. Now in Section 5.6, we're going to solve absolute value inequalities. Let's do an introduction first. So we have the absolute value of x equals 4, and that means that we need to find the distance between x and 0, and that distance would be 4. So we would find two numbers that had a distance of 4 between 0 and that number, which would be -4 and +4, since both are 4 units from 0. Therefore, if I wanted to find the absolute value of x that is less than 4, that would mean that the distance between x and 0 is this time less than 4. So therefore, the distance would have to be in between -4 and +4. So it would look like this on the graph. So once again, that distance between x and 0 this time has to be less than 4. So it's going to be anywhere between -4 and +4 on the number line. So again, when it was less than 4, it ended up being in between, so it was an and situation. So now let's look at what happens when it's the absolute value of x is greater than 4. That means that the distance between x and 0 this time has to be greater than 4. So once again, absolute value of x equals 4 means it's -4 and +4. So this time it's going to be outside of -4 and +4. So it would look like this on the number line. So if you can see here, this time it was greater than 4 and ended up being an or situation. So one more time, if it's less than, it's going to end up being an and situation. If it's greater than, it's going to end up being an or situation. I have an easy way of remembering this, which will be on the next slide. So here's the easy trick to remember the difference. If it is less than or equal to, you will have an and situation. And here's the trick of how I remember it. If I have a less than symbol or even a less than or equal to symbol, I can put an A with a long tail. That A stands for the A in and. So again, if it's a less than symbol, I can put an A with a long tail in it, so indicating it's an and situation. If you have a greater than or equal to sign, it's going to be an or situation. And the trick to remembering that is if it's an or situation, I have it like this, or greater than or equal to, I cannot put the A with the long tail in there because I can't continue it this way because I'm blocked by the symbol. So again, an A with a long tail is for an and situation. I cannot put an A with a long tail in here because I'll get blocked by the symbol, so it has to be an or situation. This is literally how I remember it, the A with the long tail, or I cannot put the A with the long tail inside the inequality symbol. This will work as long as the absolute value is on the left-hand side of the inequality. So in this case, I know this is an or situation because I cannot put an A with a long tail in there. If it was the absolute value of x is less than 4, then I can put the A with a long tail, so I know that is an and situation. This is how I remember it, and this is how I will refer to it in class. Now that we've talked about how to identify whether you have an and situation or an or situation, let's now talk about how to solve the equations. And the best way to do that is just through examples. So here's example number 1. Solve the inequality, graph your solution. So the first problem is the absolute value of x is greater than 2. So the first thing I'm going to do is realize that this is an or situation because I cannot put an A with a long tail in there. So it is an or situation. Because it's an or situation, I'm going to set up two problems. The way I set up those two problems is first to take the absolute value bars out and just leave it as it is. The second situation would be x is less than -2. So you flip the inequality sign and make it negative. So again, the first situation, you just take the absolute value bars out. The second situation, you take the absolute value bars out, flip the inequality sign, and make that number negative. So my two answers would be x is greater than 2 or x is less than -2. So when I graph it, I would actually put this number down first since it is less than this number over here. So it would be an open circle at -2 going to the left and an open circle at +2 going to the right. So once again, this is how I would set up and solve an or situation for an absolute value inequality problem. Now let's look at an and situation. Here's example number 2, solve the inequality, graph your solution. So we'll start with the absolute value of x is less than or equal to 1.5. So taking that inequality, we can see that we can put an a with a long tail in it, meaning this is an and situation. We'll set up the and situation just like we did the or situations. Our first case is where we take the absolute value bars out and leave it as it is. Since this is an and situation, I have x is less than or equal to 1.5, and I have x is greater than or equal to negative 1.5. So again, you take the absolute value bars out for the second case, flip the sign, and make it negative. But again, this is an and situation. We don't normally write and situations as two separate inequalities. So we're going to write it as one compound inequality. So remember, we write our less than first. X is less than or equal to 1.5. Now I'm going to take my negative case and put it over here, which means I'll have to flip this sign around. So now this literally means that x is between negative 1.5 and positive 1.5. So to graph it, I'd have filled in circles at negative 1.5 and a filled in circle at 1.5, and then I'll shade in between. So once again, this is how you would solve an and situation absolute value inequality problem. Here's example number 3, a little bit tougher problem. Solve the inequality, graph your solution. So first we see the absolute value of x plus 2 is greater than 1. So looking at that inequality symbol, I cannot put an a with a long tail, meaning this is an or situation. So I already know that when I go to graph it, I'll have one going this way and one going that way. So let's set up our two cases. The first case, we take the absolute value bars out, and we'll solve it normal as it was without the absolute value bars. Our second case would be take the absolute value bars out, flip the inequality sign, and make it negative. So now I have two cases. X plus 2 is greater than 1, or x plus 2 is less than negative 1. So I'll solve them. Subtract 2. X is greater than negative 1. I'll subtract 2. X is less than negative 3. So here's my two answers. X is greater than negative 1, or x is less than negative 3. Negative 3 is actually smaller than negative 1, so I'll graph that first. It'd be an open circle at negative 3 going to the left, and negative 1 is an open circle going to the right. So once again, I had an or situation. I split it up into our two cases. You do not write or situations as one compound inequality, so I just left my answer as it is and graphed it. And here's our last example, number 4. Solve the inequality, graph your solution. This one's even a little bit tougher than the last one. So notice we have the absolute value of 2x plus 3 minus 4 is less than or equal to 5. So this time we have something on the outside of the absolute value. Just like in the last section, my first step is to get the absolute value by itself. So I have the absolute value of 2x plus 3 is less than or equal to 9. So looking at that inequality symbol, I see I can put an a with a long tail in it. So that means this is an and situation. Just like with the or situations, I'll set it up into two cases. Take the absolute value bars out, leave it as it is, so less than or equal to 9. Our second case, take the absolute value bars out, flip the sign, and make it negative. So I'm going to still solve these separately, and then I'll write them as one compound inequality. So my first answer, I will subtract 3 from both sides. So I get 2x is less than or equal to 6. Divide both sides by 2, so I get x is less than or equal to 3. Remember, this is an and situation. So my second case, I'm going to subtract 3, so I get 2x is greater than or equal to negative 12. Divide both sides by 2, so x is greater than or equal to negative 6. So now I'm going to take my two answers. X is less than or equal to 3, and x is greater than or equal to negative 6. I'm going to write it as one compound inequality. So I'll first take my less than situation. X is less than or equal to 3. Now I'm going to take my other number, put it on the left-hand side, which means I need to take this inequality and flip it around. So now I see that x is between negative 6 and positive 3. So I'll have filled in circles at negative 6 and at 3. And since it's an and situation, that means everything in between, so I shade in between. And that's it for this section. You've seen examples of and situations and or situations for your absolute value inequalities. Make sure you jot down anything you don't understand so we can cover it in class, and know that we will go over more examples in class to further reinforce all of these kinds of problems. And we'll see you then.